Welcome, guys. So far in our lessons on AC circuits, we have learned how AC circuits work and how they are influenced by the presence of resistors, capacitors, or inductors. In this lesson, we'll be learning how power in an AC circuit works. In a DC circuit, the power consumed is simply the product of the DC voltage times the DC current given in watts. This is quite straightforward as both values are constant. However, for AC circuits with reactive components, that is, inductors and capacitors, we have to calculate the consumed power differently. Electrical power is defined as the rate at which energy is consumed in a circuit. In an AC circuit, electrical power is a time-varying quantity. The amount of power in a circuit at any instant of time is called the instantaneous power and is given by the equation power P equals voltage V times current I, where I and V are the instantaneous values of the current and voltage. But instantaneous values vary. The average power gives us a better idea of the power supply to our load, just like root mean square values do for current and voltage. So average AC power is equal to IRMS times VRMS times cos phi, where phi is the phase angle of the circuit and where VRMS is the root mean square voltage and IRMS is the root mean square current. Cos phi is known as the power factor of the circuit. The power factor of a circuit is the ratio of the real power absorbed by the load to the apparent power flowing in the circuit. It is also the ratio of the total resistance R in a circuit to the impedance Z of the circuit. And this power factor can vary from -1 to 1. Now, what this factor actually measures is the effect of the power dissipated in the reactive components of the circuit on the real power in the circuit. Remember that the reactive components in the circuit are capacitors and inductors. They are the components that provide a reactance, that is, a resistance to the changing electric field. The power dissipated in the resistance is given by IRMS squared R, while the power dissipated in the reactive components is given by IRMS squared Z. So let's go back to power factors. A power factor of 0 means that no power is dissipated in the inductor or capacitor, while a power factor of greater than 0 yet less than 1 means the voltage and current are not in phase, and therefore not all the power generated is consumed by the load. A power factor of 1 means that the voltage and current are in phase, just like in a purely resistive circuit. This means that all the power is converted to work, whether as heat, light, or other energy forms. While a negative power factor means the device is generating power, which flows back to the source. In other words, the load has surplus power and is now supplying the source. So join us in our solved problems on AC power to learn how to calculate the average power and power factor in an AC circuit. See you there.